Back to another exciting calculus lesson where we get to talk about actually estimating different limit values. This will cover both sections 3 and 4. And what we have going on here is we're going to use some graphs and we're going to use tables. Both of them are very easy. Once you get the hang of it, they're not very time consuming, so we can do 2 sections at once without too much problem. So first let's look at this graph. It's very important that we remember that a limit is not necessarily what's happening at a particular x value or the c value, but what's happening very close to that x value. So sometimes the limit is equal to the function value, sometimes the two things are very different. So let's talk about some of these, starting up here with the limit as x approaches -4 of f of x. So our function here is named f of x, and we're going to talk about what happens when our function is getting really close to -4. Okay, so some people like to think of it as we're tracing along this function. As we get close to -4, there was no direction there, right? Nothing from the left or from the right. So we have to look at both sides. And as I get close to -4 on both sides, my function value is getting really close to this open circle. So I would say that this limit is equal to that y value there at that open circle, which is 2. Okay, now that's not the same as saying that f of -4 equals 2. That's not true because of the open circle, but limits and function values are oftentimes very different. Okay, so let's look at another one. The next one asks us to approach +1 from the left. So here's where +1 is, and we're only looking at the branch that comes at +1 from the left. So right here, and that branch is approaching this y value of 4. So we would say that limit is equal to 4. The next one says we're going to approach 1 from the right. So I'm looking only at the branch of the function that's coming from the right and getting close to -1. So I'm coming here and I have an open circle, but open circles can be limits too. So we say that limit, our y value, is getting close to -2. Okay, now we have f of 1 here. F of 1, that is actually asking for the function value at 1. So if we're looking for a function value, it has to be a point on the function. Okay, when we look at 1, we have 2 options. We have the 1 up there at 1, 4, and we have another thing down here at 1, -2. We have to go with the closed circle, because that means it's actually equal to that. The open circle would not be equal. So f of 1 is equal to 4. We have a couple more limits to look at. This time we're going to approach 6 from the left and from the right. So from the right is first here on the left. So coming at 6 from the right, we get close to that y value of 5. The next thing has us coming at 6 from the left, so we're looking at this region, and again we're getting close to that value of 5. And now the last thing asks us to do f of 6, and f of 6 is again a closed circle. It has to be the point, so when we go to 6, our closed circle is there at 2. Now, things to observe from this slide before we move on to another example are this. Sometimes our function values are equal to one of the left or right hand limits, and sometimes our function values are not equal. So anything can happen when we're talking about limits. They don't have to be equal to their function values, but sometimes they are. Let's look at a crazy looking graph. and let's see if we can find all of these limits. Let's start on the left-hand column over there. The limit as we approach -2 from the left. So think about that for a second. -2 from the left. Well, that's doing weird things. Look at it, it's going down there. We got that vertical asymptote looking thing. So we would say that is equal to, we would not say it's equal to. We would say it does not exist. If you cannot find a limit, if there's not a value there, the limit does not exist. How about as we approach 2 from the right, or -2 from the right? -2 from the right comes up here, going all the way to infinity, does not exist. How about as we approach -2? Well, now we have to look at both sides. That also does not exist because one goes to -infinity, one goes to +infinity. Let's talk about what happens in this region of 0 when we're approaching 0. When we approach 0 from the left, we're looking here. That looks like it's maybe -1/2. That's a best estimate. Okay, what about when we approach 0 from the right? 0 from the right is up here, going to 3. And then what happens as we approach just 0? 0 takes in consideration both the left and the right, and this limit that's not one-sided, the two-sided limit will only exist when the left and the right are the same. So because -1/2 and 3 are not equal, the limit as we approach 0 does not exist. And D and E for does not exist is completely approved by the AP board, so get used to that notation and use it as often as you need to. The last 3 here, we are approaching 2. Top one, approaching 2 from the left. That looks like it might be a +1/2. When we approach from the right, that looks like it's also +1/2. And then the two-sided limit, because 1/2 and 1/2 are the same, then we can say that that limit is actually 1/2 because those were the same. Okay? Does that make some sense? If not, ask me in class tomorrow. Here's another one. Pause the video and see if you can figure out all of these limits on your own so you're understanding what's going on. So take a quick pause, fill them out, and then come back and check. All right, let's see how you did. As we approach 3 from the right, 3 from the right, I think you should get 3. 3 from the left, you should get 2. H of 3 is 2. The limit of H, both sides, because the left and the right are different, does not exist. As we approach -1 from the left, looks like 1. -1 from the right looks like -2. So then the limit, two-sided limit at -1 does not exist because they're different. And H of -1 is 1. Did you get those two? That's awesome. The next part is going to be not difficult, but creating tables are very tedious. We only usually do those as a last resort if we can't find any other way of solving the limit. Okay, so we will talk about how we can set the table up. You can find f of x values as using your calculator, and you will see what the limit does there. So right here it tells us our target value is going to be 3. So x has to approach 3. We need some numbers on the left of 3 and on the right of 3. and we want to stay pretty close. So oftentimes people will start to the left of 3, maybe we start with 2. Then we have to get closer, and maybe we do a 2.5 because that's closer to 3. Then maybe we do a 2.9 because that's closer yet, and 2.99. All right, and 3 is our value that we're not choosing, so I'm just going to leave kind of a gap there. And then I need to approach from the right, so I need numbers that are bigger than 3 because to the right is bigger. So maybe we do 4, but we got to get closer, so we do 3.5. And then maybe we get closer and we do 3.1. And maybe we want to be closer, so we do 3.01, and we're getting pretty close to 3 there. Okay, now what you have to do is plug in each of these x values to our function, which is this part here. So you're going to plug in 2 and see what you get for f of x. You're going to plug in 2.5, and go ahead, use your calculator for this as much as possible. You want accurate answers. Normally in calculus we round to 3 decimal places as our rule, but for these things you will want to write, probably 5 decimal points out or something like that. And you will see that these values that you are filling in your table are all approaching some specific number here. Okay, this number, I don't have my calculator on me, so I can't really tell you what that is right now. But this number will be the limit, and then you can write limit as x approaches 3 of our function equals whatever number you find that these are approaching from the left and from the right. It is normally very obvious what that is, so you should be able to write that out. We can talk about some calculator shortcuts during class to help you out with creating these tables as fast as possible, but they are just going to be a little bit tedious. Let me know tomorrow in class if you have any questions.